So we have to design an NFA that has what the set of strings over alphabet 0 to 9 such that the final digit has appeared before. So we know from the question that here our alphabet is 0 to 9. Zero to 9, 0, 1 to 9. So these are alphabets from the question. So they said our language should be words such that the word begins. The word's final digits has appeared before. So our language can be, let's see. So let's take guesses. A number like 0, 0. So 0, 0. The first one has been seen before. Oh, so easy. 0 for this language. We have every language. We start from length 0. So here a string like 0 cannot be accepted because, yes, it cannot be accepted because the final hasn't appeared before. You see, it doesn't make sense. So we start from strings of length 2. So 0, 0, the final one has appeared before. That's this time it's appeared here. So you see, we can have 1, 1, 2, 2, 3, 3. You see, and aside that, we can have numbers being between them. So something like 3 zeros. So this one, there's 0 between, something like 0, 9, 0. You see, there's 9 between. So it will be an infinite language. We can have even 9, 0, 1, 9. You see, 9 has appeared before, so it should be accepted. That's the final one. So how do we get something like this? So first, this you can use n+1 to get a number of states. So what do? So you have to visualize, like think about it in your head. So something like this. Let's just start from our Q0. So from Q0, now we know that a string of length 2 should be accepted. So okay, here you see you can use n+1. Yes, you can use n+1. So we know the minimum string should be of length 2. That's the minimum. So 0, 0. So we just add 1 to it, making 3 states. So Q0, Q1, and the end, the finishing one, let's see, QF final. So now you see we can have a number like 0, 0 should be accepted. So we start 0, 0 should be accepted. Now 1, 1 should also be accepted. So you do this for all of them, but I didn't want to do that. That's why I just did 2 states, and that's why I stopped. So here, upon seeing 1 we move, upon seeing 1 we move. So you see the ellipses there, and our 9, Q10, because it can be 0, 1, 2, 3, 4, 5, 6 up to 9. So this is our 9th one. This also goes when it sees 9. So you see, now something like 3 zeros, how will this be accepted? So think about it. You see something like 0, 0, 0. Where should it go? Should recur. So 0, 0, 0 should recur here. So it can be 0, it can be even 9, 0, 9. So any other digits should be accepted here. 0 to 9, 0, 1 up to 9. So you see here I can use epsilon to represent the sigma to represent the alphabets. So that's why in the B I used sigma. So I won't be using this again. So here too, at the beginning too, let's say we have a number like it can start with any number. Let's say something like in our language 1 0 1 0 1 0 9 1. So a number like this, you see 1 has appeared before. This is the beginning. It started with 1 and now it is ending with 1. So something like this, how we do it? So 1, you see 1, so each of them, when it start with 1, now it takes this route instead of this. So if you start with 9 or any like 9, it will pass here, 8 will pass here, you see the ellipsed one. So that's how it goes, and you do your recursion here. So upon seeing any alphabet, it can stay here. So 1 0 9, so 1 0 9 1 is accepted. You see, so that's why the recursion here. So here too can be on seeing any alphabet. So is this all? Let me see here too. We can repeat here too, and here it should be. Here's the accepting state. Here we can recur because they said the final one. So we can recur when it gets here. That's all. Here is the beginning. It can start with anything and have 0 being 0 here being the acceptance state when it has already seen 1 0. So that's how it is.